So, we were just talking about me automatically grouping things in my head when I think about the last World Cup. Let's just go through the groups I have up here. Maybe you can add some more to my list. So these were the groups I thought of. The first one was the list of players from all the 14 countries. Pretty simple, right? You can easily fill this out. Let's try filling it out. Not very difficult. We can easily fill it out. Here are all the 14 countries. We have the players. Not so bad, right? The second group I thought of was the list of batsmen who scored a century. Not so easy anymore. But still, with the amount of stats that are available these days, when you look at a match, actually, the stats are impressive. It could actually be a fun career option if you like statistics and like cricket. So, enough stats available, filling in batsmen with a century, not difficult again at all. Right? We filled it in there. Those are all the batsmen who hit a century. Let's try something more fun. What about players who played well? This should be fun, right? Kohli, I think, was fantastic in the World Cup. Other than the semis, I wonder what happened to him in the semis. He probably underperformed due to, too much pressure. Clearly, it's going to be tough for us to agree, right? I'm not going to get into this back. Let's keep this group aside for a minute. Let's try to think of if there's an easier group. What about bowlers who batted well? That could be a fun group. I'm guessing not. So that's again not very easy to fill. So what's happening here? There are some groups that we came up with which were much, much easier to fill than the others. Right? Let me just separate them for you. So we already have them. What we had on this side are the groups of batsmen who scored a century, players in the World Cup, easy ones to fill. Right? The ones on my other side, on my left, are much harder to fill. Why do you think it is so? Exactly. The easier to fill groups, these are facts that none of us can disagree, or we can say that they are well defined. The groups other than these are completely opposite. They are based on opinion and not at all on facts. And each of us is entitled to have a different opinion, right? Like Kohli, according to me, is an amazing player, and he played very well in the last World Cup. Okay, wait. I'm not trying to make that. Hear me out. Let me complete what I'm saying. What I'm saying is that I feel that he played well, but a lot of you do not feel the same way, right? So there isn't one answer to this question, to the question of whether he played well or not. So in this case, the group is not well defined. So what we have for ourselves up here are two kinds of groups. One, which are well defined, which are based on facts, which are to my right here, and one, which are not well defined, which are based more on opinion rather than fact. So if we are given a player, we are going to find it very hard to either place him in the group or not place him. Right? The kind of groups that we have to my right are what we call as sets, and the kind that we have to my left are simply groups. They are not really set. So what we've seen is sets are a well-defined collection of distinct objects. In other words, a well-defined group. Very easy, right? If we were to write the set of players in the World Cup 15 team, Indian team, we just list down all the players, separate them by commas, add curly brackets, and we have a set. As simple as that. Every object in this group, a player in this case, is called an element of the set. And well-defined, we saw, meant that given an element, we can be sure whether it belongs to a set or not. Lot of new words we are learning today, right? Let's keep a list of them for our ready reference. So we have sets, we have elements, 2 words so far. We'll keep adding to the list as we go. Let me ask you a simple question. Write down the set of all cricketers who have ever played in the World Cup. I see some of you have already started religiously writing down a list. Some of you are giving me a look as if I'm crazy. So even if you knew everyone who ever played the World Cup, it's going to take ages to list all of them down. There's got to be a smarter way of doing this, right? Fortunately, there is. Mathematicians are pretty lazy. It's a good thing to do. If there's an easier way of doing something, they'd be sure to find it. So I'll simply write this as Team World Cup is a list of all X, such as X has played a cricket World Cup. If I want to be more precise, I'd say X such that X has played at least one cricket World Cup. What have I done here? Instead of writing down every element, I just wrote down the common property that each element of the set possesses. So if we write the set of all batsmen who scored a century, we'd say X such that X scored a century in the cricket World Cup. You could do the same thing with boring mathematical sets like natural numbers too. N is a set of all X such that X is a natural number. This way of representing sets is called the set builder method. The earlier method where we listed down everything, was called the listing method. So we've seen two ways here, right? The first way where we list down everything is called the listing or the roster method. We'll put it up there. And the second form is called the set builder method, where we talk about the common property. Seems like we should always use the set builder form, right? Listing is far more tedious and time consuming. Now try representing this set in the set builder form. You have set A and it has all of these people. Try listing this. Try it out. Not so easy anymore, is it? The problem is it's very difficult to come up with a common property to represent just these elements. Listing would be a much easier method here. So the key is to be lazy and pick the method that is easier in the given situation. So two more new words for our list: listing or roster method and set builder method. Let's move on. I've always wondered how many people in this country play cricket. Suppose you want to form a set of all Indians who've played cricket at least once in their lives. How many elements do you think such a set could have? It's going to be really, really big set, right? Almost everyone I know, be it a girl or a boy, a kid or a grandparent, everybody seems to have played cricket at some time or the other in some form or the other. So yes, this is going to be a really large set. But can we count it? We sure can, right? We count the entire population of India during the census. We can certainly count the number of people who've played cricket. So you can count it, you can give it an actual number. Hence, this is a finite set. Whereas, if you look at something like the natural numbers, you can't count the natural numbers. They go on and on and on. It's a never-ending list, right? There's no end to it. So you can't count it. Such a set which you cannot count is what you would call an infinite set. So the natural numbers would be an infinite set, but the set of Indians who like to play cricket, even though a very large set, is still finite. There is a definite end to it. There are a definite number of people who fit into that set. Hence, it's a finite set. And if you think about any other sets that we discussed so far since the beginning, all of them were finite sets. There were a particular number of elements and we could count all of them. In fact, if you have to use the listing method, the set has to be a finite set. Otherwise, you can't list it. You need to, by definition, list all elements, right? If you don't know natural numbers, till where will you write? It doesn't end at all, right? All your life you'll sit writing, it will still not finish. Correct? So whenever it's an infinite set, by default, you have to represent it in a set builder form. You cannot do the listing method in that case. Right? So if we were to say, write the list of, all the balls that were ever bowled, or the speeds at which the balls were ever bowled in any match, the number of runs that were scored, the number of runs that were scored by a single player, all of these would be really, really large sets, but they would still be finite sets. Something more abstract, like the number of points on a cricket ground. I'm starting to get mathematical again, right? Most infinite sets, unfortunately, are mathematical in nature. So something like that, right? All of these would be infinite sets, right? In math, something like a set of natural numbers, set of real numbers, all of these would be infinite sets. Set of points on a line, if you take a line set of points, all of these would be infinite sets. But anything which you can count, even if it's a really large number, would be a finite set, right? Two more new words: